Hi friends, welcome to VVSM Academy. I am Veerbhadra Ademaya. The classes today is PUC 12 standard classes, physics, Bohr's atomic model. Well friends, today before going to discuss about the Bohr's atomic model, we should know about the structure of atom. Atom consists of electrons, protons and neutrons. The protons and neutrons are packed together in the nucleus, and the electrons which are revolving around the nucleus of an atom. This is the fundamental structure of an atom. Bohr's diagram shows electrons orbiting the nucleus of an atom somewhat like planets orbit around the sun. In the Bohr model, electrons are pictured as traveling in circles at different shells depending on which element have. Each shell can hold certain number of electrons, that is principal orbitals K, L, M, N, O, P, and suborbitals SPDF orbitals. This is the great scientist by name Niels Bohr. Danish physicist used the planetary model of the atom to explain the atomic spectrum and size of the hydrogen atom. His many contributions to the development of atomic physics and quantum mechanics, his personal influence on many students and colleagues, and his personal integrity, especially in the face of Nazi oppression, earned him a prominent place in history. Credit unknown author via Wikimedia Commons. This is a great scientist, Niels Bohr. Bohr combined classical and early quantum mechanics concepts to propose a three-postulate theory. The first postulate tells about the electron in an atom revolves in certain stable orbits without emitting radiant energy. Each atom has certain definite stable orbits. Electrons can exist in these orbits. Each possible orbit has a definite total energy. These stable orbits are called stationary states of an atom. An electron can revolve around the nucleus in an atom only in those stable orbits whose angular momentum is the integral multiple of h by 2 pi, where h is the Planck's constant. If the mass of the electron be m and it's revolving with the velocity v in an orbit of radius r, then its angular momentum will be mvr. According to Bohr's postulate, mvr is equal to nh by 2 pi, where n is equal to 1, 2, 3, which are called the principal quantum number of the orbit. This equation is called Bohr quantization condition, that is v is equal to ef by ef minus et, ef by et, where this is the Bohr's frequency condition. An electron can make a transition from its stable orbit to another lower stable orbit. While doing so, a photon is emitted whose energy is equal to the energy difference between the initial and final states. If the energy of the initial and final states are EI and EF respectively, then the frequency V of the proton is given by V is equal to EF minus EI divided by h, where h is the Planck's constant and ef and ei is the energy ei, initial, energy final. Electrons can only revolve in those orbits in which their angular momentum is an integral multiple of h by 2 pi. The postulates I am telling you. And similarly, the V is equal to E2 minus E1 by h. Inside an atom, the electrons which are revolving around the nucleus of an atom in principal orbitals K, L, M, N, O, P. This is the Bohr's atomic model. Bohr's diagram show electrons orbiting the nucleus of an atom somewhat like a planet's orbit around the sun. In the Bohr model, electrons are pictured as traveling in circles at different shells which are principal orbitals, depending on which the element you have. Each shell can only hold certain number of electrons. Each and every orbit has got a definite number of electrons. Both diagrams shows electrons orbiting the nucleus of an atom, somewhat like planets orbit around the sun. We have discussed principal orbital 1, 2, 3, 4. K, L, M, N are the principal orbitals. The center is the positively charged nucleus. Thank you for listening. Please like our videos and don't forget to press bell icon, my dear friends, so that you can have a forthcoming videos on physics, modern physics. Thank you. Like, share and subscribe.